Alright, so we're going to watch a bunch of videos on Bohr models. I actually stole one off the internet, don't tell anybody, because they did it way better than me, but this is a Bohr model. This is a magnesium. It has 12 protons, 12 neutrons, and this is the nucleus in the middle right there. That doesn't count as a ring. It has 1, 2, 3 rings. These little dots are electrons, so it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 electrons in 1, 2, 3 different shells. So for this stuff, I want you to make sure you have a periodic table. We're going to be looking at these first 3 periods, and I'll let the video explain them more, but you're going to be making 3 different Bohr models of your own. Obviously not magnesium, but the ones in the video. But apart from that, enjoy!
Alright, in the following demonstration we're going to be learning about Bohr models. And one of the things we use Bohr models to do is try to understand what the atom would look like. Now, just as in any atom, or excuse me, any model, this isn't really what the atom looks like, but it helps us understand how it works, how it behaves, things like that. So just keep that in mind. So if we take a look at hydrogen, we have atomic number of 1, we have an average atomic mass of 1.008. So first of all, I need to get the protons, neutrons, and electrons. There'd be 1 proton based on the atomic number. Neutrons, we take this, round it to the nearest whole number to get our mass number, which would still be 1. We subtract that from our atomic number, so 1 minus 1 gives us 0. Neutrons, we're going to assume that all these Bohr model examples that we do are neutral in charge. And so the protons are always positive, the electrons are negative. So if this is going to be neutral in charge and there's already 1 proton, there must therefore also be 1 electron. Now, when we do the Bohr model, first thing we need to do is draw the nucleus. So we've got P equals 1, N equals 0. There's our nucleus. Now we have to draw the first energy level. The energy levels, or the orbitals, are where the electrons are. This is the body of the atom that holds the protons and neutrons. Here is our energy level that holds electrons. And we have 1 electron. We're going to put it right up there. That's the Bohr model for hydrogen. Next, let's take a look at helium. If this is our helium, we can see the atomic number is 2, so the protons are 2. The neutrons, we round this to get 4. 4 minus 2 is 2 for the neutrons. We assume that it's neutral. If it's neutral, and the protons are positive with 2, the electrons are negative, must also have 2. I'm going to draw my nucleus. Protons equal 2. Neutrons equal 2. There is my nucleus. First shell is how there's just going to be 1 shell for helium, and there are going to be 2 electrons there. Here and here. Now the first shell of a Bohr model, we can look over here at the periodic table. On the periodic table, the first shell corresponds to the first period. Periods go side to side. Groups and families go up and down. So here's the first period right here. And in the first period you can see there's 1, 2 elements. Since there are 2 elements in the first period, you can also only fit 2 electrons in the first energy level. You can see that the second period has 8. 1, 2, 3, 4, 5, 6, 7, 8. So it can fit 8 electrons in that shell. And the third period has 1, 2, 3, 4, 5, 6, 7, 8. And that's as far as we'll go with these standard Bohr models, because after that the model starts to fall apart somewhat. Next, let's look at boron. If I have boron, atomic number is 5, and again I know it's the atomic number because it's smaller of the 2 numbers, so that means the protons are equal to 5. Neutrons, I've got to take my atomic mass, round that to 11. 11 minus 5 gives us 6 for the neutrons. We're going to assume it's neutral still, so if there's 5 positive protons, then the electrons must be 5 as well. In this one I've got my protons equal 5, neutrons equal 6. First shell. We always need to fill a shell before we move on to the next shell. So if we look over here, the first shell can hold 1, 2 electrons. So we do have to put 2 electrons right here and here. And for our state, we're going to put them right here next to each other, paired up, because they want to be together. You'll find other models where they do them differently, but again, just like a map, you can color the states different colors if you wanted, but it still represents the same basic information. Next, we're going to do the second shell. And here's our second shell. Our second shell, if you remember, can hold 8. 1, 2, 3, 5, 6, 7, 8. But we don't need it to hold 8 because we only need a total of 5. We already have 2 on the first shell. And so we obviously need 3 more. Here's where we're going to put them. We're going to put the first one on the top, the right, and the bottom. So we're trying to space them out at first. And that's the Bohr model for boron. Next, let's look at the Bohr model for neon. For neon, atomic number is 10, so the protons must be 10. Neutrons, we take the average atomic mass, 20.183 minus 10 gives us 10. Electrons, if we assume it's neutral and there's 10 positive protons, then the electrons must be 10 as well. So write my nucleus. Protons are 10, neutrons are 10. First shell of the Bohr model can hold 2. 1, 2. And it does. We always have to fill up each shell before we go on to the next in this case. Next shell can hold 8. 1, 2, 3, 4, 5, 6, 7, and 8. And if we look here, we have a total of 10, so our second shell must have all 8 of those. Here's how they go. Top, right, bottom, left, top, right, bottom, and left. And again, you'll see different ways to put those on. Once you get to official chemistry, you'll do it probably a little different, but for right now, this would be fine. So here is our neon. This is also an important thing to point out. Neon is part of the noble gases, and again, these are all the noble gases running down in this family from here. With the noble gases, the thing about them that's important, their outer shell is full, and because their outer shell is full, they're happy. They don't want to bond with other things because bonding involves the transfer of electrons. Every atom wants to get to this state where their outside shell is full, and neon is in that state. Next.